EKG of the week. Let's look at another 12-lead EKG and walk through it. So take a look here. Pause the video now and interpret this EKG and restart the video when you've got an idea of what you think is going on. All right, hopefully that's given you enough time to do so. Let's look at this EKG. So again, we'll start kind of algorithmically. And, for this one, let's just let our eyes kind of wander to what we see and what they're drawn to start with. And that is that this looks weird. This does not look like a normal EKG. And this looks concerning to us probably. And just the first blush on this, you're going to say, well, this looks like ventricular tachycardia. Okay, maybe it is, but let's go through it. Let's take a peek. Let's analyze this thing. So let's start with rate. Again, probably the easiest way to do it is to count the number of QRS complexes across the strip. You could also do it going beat to beat here. So if we went beat to beat, there's this might actually work out pretty well because it's pretty regular. So 300, 150-ish comes up a little before that, so a little more than 150. Rate, somewhere around 160. If we count them at the bottom, it turns out to be 26. Which gives you rate of somewhere around 156. So 150 to 160. Tachycardic, certainly. Right around 150, 160. Not at 150 itself, just FYI. Rate, how about rhythm? I'm going to say we look on here, and we look for P waves, and we don't really see any P waves. Okay. Now, they may be hidden in these QRS complexes. It may be that there's a P wave in the middle of this T wave, but I just don't see any evidence of that right now. And 156 is fairly fast for a sinus rhythm anyway. I don't think this is probably sinus rhythm. Could this be a fast AFib that looks fairly regular because it's so fast? Maybe it could. It's hard to tell. The beats all seem to march out. They look pretty darn regular, so I'm going to say it's maybe not AFib, but that gets in there as well. And that kind of leaves, you got a regular, at least from what we can tell, we're not sure if it's sinus or what the rhythm is, so I'm just going to say unclear. But if nothing else, it is a tachycardia, and it looks regular as best we can see. So a regular tachycardia, even if we can't define the rhythm itself otherwise. All right, so we've got rate and rhythm. Let's look at axis itself. Axis can be kind of hard to determine. We got to first figure out what exactly we think the QRS complex is and what's the T wave, etc. So I think that this thing here, and this shouldn't be terribly hard to figure out. I think this is the essentially the T wave component, and this is the QRS, which would correspond with this guy here. So looking at our axes, we look at lead 1. We are mostly positive in lead 1. And in lead 2, we're negative in lead 2. So we're already kind of talking about likely left axis, and looking at the same thing in lead AVF. This is going to be a left axis, and again, look at it on a chart if you don't believe me. But positive 1, negative in 2, negative in AVF gives you a left axis. How about the intervals themselves? Hard to tell because we don't see any obvious P waves, so difficult to tell about the PR interval. If it's in there, it's buried someplace, we just can't tell. But we'll call this a likely wide complex QRS, certainly. Again, the number is 3 beats, or 3 boxes. So 1, 2, 3, greater than 3 gives you a wide complex QRS, 3 little boxes, that is. How about the QTC? Again, difficult to tell because all the beats kind of line up together, but it looks like that between the beats that the T wave doesn't necessarily finish before halfway between those 2 beats. So this is probably what might be a long QTC, but the morphology doesn't match up with what we normally think of, but probably long QTC if you were to actually sit down and measure it. So let's call it wide QRS if nothing else. Maybe there's a long QT. It's tough to tell. It doesn't necessarily look like any specific bundle branch block or anything like that. And again, we can't tell about any AV blocks because it's too fast, and if there are P waves in there, they're buried. But we're becoming increasingly not sure that this is a sinus rhythm at all, and this is probably something else. So rate, rhythm, axis, intervals, and blocks. How about ischemia and infarcts? It's, again, difficult to tell about ischemia. we don't see any obvious like marked ST depression other than right kind of here in V2, but the faster you go, the more ST depression you tend to get generally. So this might be a little sign of ischemia, but we don't see it reproduced anyplace else. We just see these big, wide, broad QRS complexes leading into the T wave, and it makes it difficult to tell. But no obvious ischemic changes that we can see. How about infarct-wise? I'm just going to say I don't see anything that I can obviously call or differentiate to be a STEMI. And that's usually the case in what we think is coming up next. It's not really clear, but we also said from the outset that we think this is probably a ventricular tachycardia, and one of the most common reasons for someone to develop ventricular tachycardia is ischemia and STEMI. So if not for other reasons, if they don't already have something predisposing them to it. So while I can't say that there is a STEMI, this is certainly concerning. I would say anybody that's in VT that has not been in VT before, I am certainly concerned for ischemia and potentially infarct. How about patterns? We mentioned already that this looks like VTAC to us. And when you think about it, why do you say that? Well, there are a couple of things. One, it's regular. The interval between each of the beats looks pretty much the same each time. So it's regular. It's wide complex, we've already established that, and it's fast. So wide complex tachycardia, you always have to be concerned, could be VT. There are other things that do it. For instance, an SVT with a left bundle branch block will give you a wide complex tachycardia, but it's not VT. This doesn't obviously scream left bundle branch block just looking at the thing, or right bundle branch block, or something like that. It looks more kind of a monomorphic VT. All the beats kind of look the same, and they don't follow a specific characterization. There are a couple of little signs that you can use to pick out maybe ventricular tachycardia versus another one. And I'll just draw my own thing for a second. If you look at the ventricular beat, there's two parts of it that are sort of the classic signs. One is a R to S interval greater than 100 milliseconds, or 2.5 little boxes. So the start of the R wave, and you got to find an R wave, which in this case is going to be in V2. The start of the R wave to the point of the S wave, that distance should be, if it's more than 2.5 little boxes, that's concerning for ventricular tachycardia. Likewise, I drew this little guy down here, this little notch near the bottom of the S wave, near the bottom of the big negative deflection there. That notching is concerning or potentially indicative of ventricular tachycardia as well. So an R, and again, you start at the beginning of the R wave, R to S interval of greater than 100 milliseconds, or 2.5 little boxes, or notching in the QRS in absence of typical morphology for anything else, leads you to think this is probably VT. So does this person have that? Let's look real quick. When we zoom in on V2, is the R to S interval more than 2.5 boxes? It looks like the R wave starts here. There's 1, there's 2, and it's probably right at 2.5 little boxes. So right at 100. Let's call it maybe concerning. When I look through here, I don't see a whole lot of notching, which would help us out here. I think there's an occasional beat in here or so that has, just a little tiny bit of deflection kind of right there, but not the clear notch that we're sort of looking for. So is it super easy to pick out VT versus SVT with an aberrant conduction like a bundle branch block or an accessory pathway or something like that? It's not always easy, but those are two things that you can kind of use with it. So if it's regular, if they've never had VT before, if it is wide complex, and if the R to S interval, again, the start of the R wave to the nadir of the S wave, if that's more than 2.5 boxes, or if you see notching at the bottom of the S wave near the nadir there, then that's concerning for ventricular tachycardia. So let's put a final interpretation on this. We've got a wide complex. If nothing else, we can say this is a wide complex regular tachycardia that would be concerning for VT. And I think this is probably VTAC. So the providers involved with this person's care actually did cardiovert this person and ended up with the following EKG here. And it also is abnormal, but we'll tackle that one at some other point. So this is likely VT for the reasons that we kind of talked about. But again, it's tough to tell. And the nice thing is that if you don't know, you don't necessarily have to know that it's VT. If they're unstable, you shock them. And you presume kind of everything else might be, but if they're stable, you don't necessarily have to do a whole bunch with them, that being the definition of stable right now, and let somebody else figure it out. Call it a wide complex regular tachycardia. Be concerned about it. Get pads on the person, but don't flip out if they got a pulse and they're talking to you. So, wide complex tachycardia, they are out there. They are difficult to tease out, but hopefully this gives you at least a little bit of an idea. So, we will catch you next time. Stay safe out there.